Hello, my people, and welcome to Optimizing CI/CD Pipelines for Faster Time to Market, a Senior Manager's Blueprint. In this presentation, we are not just going to be discussing some theory. What I want to also share is the experiences that we can use in order to improve. It is not just a matter of creating things. We should also think on how we're going to optimize what we already have. And today's topic is going to be those CI/CD pipelines that we need to keep as efficient as possible. In the agenda that we're going to have today, it will be an introduction we should never miss, some key concepts so we can all speak the same language, the strategic importance of doing this kind of activities, some case studies which are pretty much the experiences that we have had in the organization, which have led us to start optimizing what we already have, leadership and culture, which is how important it is to involve the leadership team and add a culture of thinking on improvements inside the organization. And finally, a connect with me. Okay, my people, now let's start. First thing is, nice to meet you all. I am David Ayala. I work as a senior manager inside the delivery management team in Veritas Automata. Those tasks that you see there are the price that I get for telling bad jokes inside the meetings. But what I truly do is working with the quality team to make sure that the clients receive a product with quality, to make sure that everything is working and meeting the expectations. Now, the real purpose behind this specific slide is why are we here? Why are we making this presentation in the first place? First thing is time, my people. It is a valuable resource that we cannot waste. Time is something that we want to use as productive as possible. So if you are doing something that is taking too much time, that is something that you need to start checking because you want to make sure that you are spending the right amount of effort in the right activities. That is why it is so valuable to start checking how much you need to do something. Now, if my product works, can I touch it? So what happens here is that it is something that I heard too much in the university when I had to deliver a laboratory. It is working, so I should not touch it. Don't touch the circuit. Don't move the code because it is going to blow. But we are now in an environment where we must think on if it is working, why is it working? And if it isn't working, why it isn't working? So those are the real questions that we should be making. We should understand how our products, how our services, how our systems work in order to know how can we start escalating them, improving them, how can we start customizing them for us. Now, stabilize for production, but also for you. It means that sometimes we are always thinking our businesses on how we can satisfy our customers, how we can make our clients happy. But what about you? What about your developers? What about all the people that is behind all that project? You must also think on them. Are they okay with the current pace? Is the way that we are taking the idea to a reality flowing as expected? Do we have bottlenecks? Do we have some pain in any place? That is why when you are working, do not just think on the end. Also think on the process, on all the steps there, and on the people there. Finally, don't react to the market. Flow with the market and eventually drive it. Initially, when you are starting, you are trying to build something that is going to be used by the end user. But there is a point or there should be a goal where you should start thinking on how you can start redirecting the user. How can you start adding things that you know and you are sure that they are going to be used, that they are going to be disruptive, that they are truly going to add value. Do not wait always for the customer to tell you, do this. Sometimes you need to say, we are now able to do this. That is why you start, maybe in the beginning, you are going to start reacting to the market, but your goal should be, I want to flow the market and eventually my decisions should drive. Now the introduction has finished, let's start with the concepts. What is a pipeline? In a technical context, with a very simplified point of view, a pipeline is just a group of jobs. Ah, perfect, okay. But let's make the definition something more fancy. It is a process. A pipeline is a process. Now we go back to the question of what is a process? If we say that a process is a group of steps that generate a result, then how can we apply this to DevOps? Because pipeline is something related to DevOps. And right now we are using some general terms. So if a pipeline is a process and a process has a group of steps that generate a result, in DevOps, how are we able to perceive that? Think on the continuous integration process that you may have in your organization or you may have seen in any theory or blog that you have been reading about DevOps. In the continuous integration, you have some steps that you need to do in order to make a piece of code become a build that you can install or deploy. And those steps are related to, for example, setting up your environment, or they could be doing the commit and doing the push, sending the information to a repository. In the repository, the build happens. Also, some testing happens. All of that could be automated. Some jobs or steps could be triggered manually. So all that process that happens there, that is a pipeline. You can see that you start with some code, and that code finally becomes a build that you are able to install and use. Another example is the monitoring. If you think on an scenario where you have something in production and you want to start monitoring that application to make sure that it is behaving right, but you also want to have a defined process from when it starts going on flames, then let's think on the following example. An application is eating resources. Then you want an alert to be sent to a dashboard application. Now, once that happens, you want that alert to also be sent to an incident management application. When that happens, you want that incident management application to alert a team that is going to be there on call, ready for the fire. And finally, you want a ticket to be created in the board of the DevOps team. That is a very simple example of how you may want incidents in a production environment to be handled. So these are examples of pipelines taken into DevOps. Now, we say that a pipeline is a process, and a process has steps to produce a result. What will be those steps? They will be a job. These steps are jobs, and at the same time, these jobs are a group of commands. Now, let's go back to the example that we had before, which was the continuous integration. If we think on all the steps that are done, most of them, they are going to be commands. You execute a lot of commands in order to make sure that the code that you're making is finally becoming something that is going to be installed by a user, okay? If we try to visualize that, it will look like this. So let's go from the whole beginning on how you are able to generate that build. First thing is you need to have the code, which means you need to clone the repository. And a command that you will do for that is doing a git clone. Now, the repository already has the changes that you previously already committed and pushed. Perfect. After that, the first thing that you need will be installing the dependencies. If you are working with Node.js, you may use something like npm install. After that, what you want is you want to build the code because you have new changes there. You want to make sure that everything is able to be built. Then you are going to execute something like npm run build. You have a command to build the whole project to make sure you have the install application that you need for that. And finally, you want to execute some unit tests to make sure that whatever you added is not breaking any logic or any business rule. So the command that you will use for that will be npm run test unit, something like that. These four commands, they are a very quick and simple summary of the processes that you may do in order to generate a new build. Now, let's talk about the strategic importance of CI/CD and some key components to make sure that you have effective CI/CD pipelines. And here you can see the image that is talking to you and is telling you continuous feedback. Why are we highlighting continuous feedback? You can notice that the image of DevOps that you always see is a cycle. It starts like this and goes back and goes back and goes back. The continuous feedback is what you can consider the last step and the first step of the new iteration or the new idea that you are going to build. In the continuous feedback, you are going to be getting info like how your application is behaving, but also how the users are using it and how they feel with that. You know the resources that are being consumed, you know the features that are truly used, and you know if the users, they truly see value or not in whatever you have delivered. With all that information is that you are able to start the new cycle again. That is how you are able to plan because you get all that info, all that input, those become your ideas. that you start refining, you start planning around them, and what do they become? They become the input for the next stage, for build, then to continuous integration, deploy, operate, and start all over again. That is why continuous feedback is so important. If you are able to gather the right information and process it as you truly need, you are going to be able to start planning and start the whole cycle again with the right goal. But it doesn't end there because we also have automation now talking to us. Why would automation be so important? Well, because here we are humans. And as we are humans, we have chiefs. And even if we wanted to give 24/7 attention to our customers, we are not going to be able to survive. So we need to start thinking on automation to make sure that some of our processes are able to control by themselves. And you can also notice that automation is surrounding everything. It is surrounding all the places. Why? Well, because in all the process, in the whole process, there are going to be pieces that you want to be able to integrate between themselves so you don't have to do all the steps manually. Automation is something that is going to save you time and it is something that is going to reduce the workload that you have in order to make sure that whatever you are building truly gets to the right place. My people, we have finished with the definitions, we have finished with the concepts. Now we are about to enter the part where we talk about those hard experiences that have led us to say we need to start optimizing. What I am going to present you are three situations that have happened to us in the organization. The situation one, we delivered the Docker files to never review them ever again. In the situation two, my pipelines were working, but at what cost? And in the situation number three, my system is modeled with an elegant legacy flavor. What is happening there? Let's find out. Let's start with situation number one. We delivered those Docker files to never review them again. What happened here is that as we have a software where we can track the hours on where we are investing them to make sure that we are properly working, something that was not that we were able to notice is that we were investing too much on building. So in the QA team, sometimes we need to move with different branches, and sometimes we need to do full builds. That means clean everything and start building and building images again. And that was taking a lot of time. That is when I say, how can we be more productive? Because that number weekly is quite high. Then we had to start analyzing the problem to see what was going on. So the problem, build is taking too much time. Switching between branches is a pain. Okay, that was the problem. But what was the source? What is causing this pain? We have Docker files without staging, leading to heavy images, and we are not taking advantage of Docker caching system by setting layers. So we found out by reviewing the, let's say, components that were very old and were delivered years ago. They were delivered, they got to the repository, and we never reviewed them again because they were already there and they were working. But as time passes, you start adding more packages, more libraries, more code, and they became heavy. And that is how we noticed that it used to be 15 minutes. Why is it taking 45? Well, because you never review again what you already delivered long time ago. It wasn't optimized. What was the solution that we had to apply? We apply staging in some Docker files to reduce the size and generate base images for other components to reduce the build time. Now you're going to say, perfect, you applied that solution. Good. And what is the result? What is the difference now? Well, in this situation, what happened is, by using stages, one component's image was reduced from 657 megabytes to 157, a reduction of 500 megabytes. If you have a team of a lot of people, say 30, and those people are constantly touching that component, that means a lot of pushes, and that could mean a lot of builds. So imagine your repository receiving builds and builds and builds with a weight of 657. That is going to be a lot. But if you optimize it to only have 157, completely lightweight. And in our case, where we have deployments, we deploy in devices that sometimes they don't have the best network. So going from 657 to 157, trust me, it makes a very beautiful difference when you are doing an update there. Now, by using a shared base image, the build time of two components was reduced to by 2 minutes each, in the CI environment and by 4 minutes each in the local environment. Because the benefit was not just about the size of some images, it was also about the speed to generate them. Because something related with the next situation that we're going to see is the time. How much time you need to build something because you're reporting too much time doing the builds locally. Well, thanks to the strategy that we applied, we ended up doing an impact, generating an impact in the cloud and also locally, where the build time started to get reduced. So the components that were taking too long, they started to get in a more decent time. We haven't reached the perfect balance, but right now it's totally a difference. That was the situation one. About situation two, my pilots work, but at what cost? This game is the perfect example. In one moment, the CI server started saying, I need more minutes, I need more minutes, I need more minutes, I need more minutes, because the builds were taking too long. So they started eating the budget. And you want to save that budget. You want that budget for your projects. Then how are you able to recover? Well, first let's start analyzing how we're using the CI server. So if we look into the details, what was the problem? Every merge train is a full build of all the apps, even if I only touch one. We also had duplicated jobs in the components where we have committed changes. So to give you the example is that if you have 10 components and you touch one, the logic that we had is that we have a job to build the component when we are in a merge train. And we had another job to build the component when a push will happen in a merge request. So it means you will have those two jobs getting triggered at the same time, doing exactly the same build and pushing it exactly to the same place. They weren't failing, but you are eating minus there, which means you are eating budget. Then what was the source? The design of all the build jobs was including a condition, one small condition, that was triggering all of them in the merge trains. What was the solution? Remove the condition that triggers the general builds. It was one condition, only one. And that condition was enough to say, I need more. So when we remove it, we finally allow only general builds on specific triggers, not on the merge trains, because if you have a big team, you're going to have a lot of merges. You don't want a lot of builds there, only the necessary. Then, but sometimes you're going to need a full builds, for example, for tagging, for versioning, those kind of things. So we still have the capability, but it is now under control. That is how we were able to solve it. And the impact will be the following. Very fast merge trains. From around 120 computed minutes of multiple jobs getting executed in parallel to just the necessary jobs, consuming less than 20. And it could be way less than 20 if you are touching components that are very lightweight. If you touch the whole project, you are going to eat the 120 because you are touching all the components in all the client. But you only touch a few pieces. You went down from 120 in parallel to only 20. That is truly a big difference. And finally, the last situation is my system is modeled with an elegant legacy flavor. So what happens is sometimes when you're starting your project, you are going to start it today, you are going to use what you will call this is the latest technology in trend, this is the latest of the latest, but you leave it there and leave it there and leave it there, and 5 years passes, and what happens there? You did not touch the version, you left the components as they were, you never updated them, you never saw if they were going to be deprecated in any moment, and now you have legacy technologies. Then, what was happening? In details, what was the issue? Well, in our case, pipelines and local builds will fail by errors with the Docker images or with NPM libraries because we have no JS projects. The source was that some technologies and libraries that we use were out of date, and we let some of them get removed by the owners before replacing them, which means only when the library was removed from the repositories, for example, the Docker official repository, that is when we finally started moving because, now it is breaking. Now we need to move. That is pretty much a corrective approach. You only move if you are finally on fire. The solution, replace those deprecated libraries and start doing POCs to rebuild components built with old technologies. Because again, you may be using the latest today, but in 4 years, is it still the latest? or is it finally out of business? Those are things that you need to keep here in mind. Now, what is the result? This situation is something that is quite big, so it is something that we have in progress, but so far it's looking really well because the builds, they have been repaired and have been stable. We haven't had these issues for a long time, and the POC that we are doing, they are showing really beautiful results. And to give you an example, we have some monoliths that are built with Node.js, and what we are doing is that we are fragmenting all of them into smaller Golang microservices. In an stable environment, the monoliths have an average response time of 5 seconds in most of the happy paths. But the Golang microservices, they have an average response time of 2.5 seconds. You may say, only 2.5. That's nothing. But hey, you want your customer to be happy, right? You want your customer to have everything as soon as possible. They want everything as soon as possible, and you want your resources to be used as efficient as you can. It means that those 2.5 seconds means availability for all the requests. So that is truly going to be a difference. Every time, every second is going to matter. Now, we have finished with the situation. Now let's start thinking on how we can start identifying this kind of situation, because we want to go from a corrective approach to something more like you want to predict and you want to prevent. Then, how can we start identifying and addressing these common bottlenecks and these integration challenges? Something that you can start considering is doing a manual audit. If you are the person that should do it, consider doing it. If you have never done it, you should schedule yourself. If you are someone who has never seen this kind of manual checks happening, you should do it. But what is this check? It is about checking the repository, check the code, check your project, give it some love to see how you are using the tools that you have added there. What is the current configuration? What are the limits that you have set there? How are the machines that you are probably using working right now? What do they have inside? So that is something that you should consider checking as detailed as possible. It is not an activity that I am saying you should do it every day or every month. No, schedule yourself to do at least the first check. And after you start doing the findings, after you identify, oh, we have some room for improvement here, that is how you can start thinking at which pace you should do this kind of manual checks to make sure that the project stays as clean as possible. Restrictions. Limit the consumption of the CI server and external services that get built on use. So remember the situation that we had where the CI server was eating budget because it says, give me more, and more minutes. You should think on how you want to prevent budget from going away, and you want to start adding limits that are going to alert you that, hey, you are getting close to the top. You should start checking what's going on in that specific scenario. So if you start adding constraints to any service, to any server that you have right now, it means that you will be able to have more control on all these tools that are part of your system. And of course, remember that if some of these tools are paid, you should consider on doing local checks before triggering any of these services. So if we talk about the CI server, and we are talking about a bill or executing tests, consider doing it locally first before going to the cloud, so you can start detecting things earlier and without spending the resources that you have there. And alert configuration. It is very important to make sure that we are notified when something is on fire, to make sure so we are able to act accordingly. So you need to start considering adding notifications on different levels on consumption. And of course, dashboards to study the behavior of usage of the system that you have right now. Dashboards, they are going to help you a lot to have a visual representation of what is going on, so you can start making conclusions and you can start acting according to whatever is happening. So you need to do a combination between what you are able to visualize and the alerts that you're going to get when you are not having your eyes on those kind of things, on these tools. Finally, to keep in mind, my people, if leadership is not aware or is not even involved, don't expect a lot of progress. The manual check that we were talking before, that is something that is going to require your time and your attention to start checking how the project is right now. And of course, as budget and time are valuable resources, This means that everyone, from the leadership to the operational team, they must understand that this is an investment with a goal in mind, which is optimizing, which is improving the efficiency of what we have right now. Okay, you need to go piece by piece. We and every organization has different levels of maturity in a DevOps process. Some organizations may have already an established DevOps process. Some organizations maybe are studying. Some of them may not even have one. You need to identify where you are so you know where you need to start doing the improvement, where you need to add something and where you can improve what you already have. That's why you need to go piece by piece. And of course, do not fear the success. Do not always expect for everything to be working. Sometimes you are going to fail, and you should not be afraid of that. Fail. If we are going to fail, we have failed. Not every POC is going to give you the results that you wanted. But remember, it will give you a valuable experience to the organization and to you, and that is going to contribute in future decisions. That is why do not be scared of the failure. Embrace the failure and make it part of the experience that you need to continue working and to continue producing. My people, we have finished. It was a beautiful journey. Thank you for joining me in this presentation. We have talked a lot about optimizing the CI/CD pipelines. We talk about these experiences. If you want to connect, feel free to scan the QR code that we have there. And thank you all for your attention. See you in the next one.